I'm going to look at the quadratic formula and the vertex formula. And these are two very important concepts in algebra. They're used in a lot of different things. And let me show you why these are important. So we've factored before. I've done a video or two on factoring before. But notice sometimes there's trinomials, there's quadratics that we can't factor. So for example, try to factor x squared minus 3x plus 1, and you really can't, right? There's no factors of 1 that are going to add up to this middle number, negative 3, because all I can do is 1 times 1, adding those would give me 2, or I could do negative 1 times negative 1, and that would get negative 2, but there's no way really to get negative 3, at least not with real numbers. So this is really a quadratic that doesn't factor, and one way I could solve this is through the quadratic formula. And this is useful because it's a formula that's able to solve any quadratic, even if it doesn't factor. And when we plot the points of this quadratic on an xy graph, it would form a shape that we call a parabola. And parabolas are very useful. I have a few examples here of just where we see these in real life. My first example, so here's an audio engineer using a portable mic, and you'll notice that this is a parabola shape to capture audio in a certain direction. Or scientists could use parabolas to build a satellite dish. It's a very good shape to capture things, to capture signal on that focus. Or my other example, here's a financial analyst using a parabola to model regression points. Sometimes they don't always make a straight line, and we need that parabolic curve to model those. So all very useful out there in the real world. Let's look at how we would solve these. So first of all, there's different ways to say these problems. So finding the roots, or finding the x-intercepts, or finding zeros, these all really mean the same thing. These are all just different ways of saying solve the quadratic for x. So if you see any of these, they all really mean the same thing. So what is the quadratic formula? This is it right here. So negative b plus or minus the square root of b squared minus 4ac all over 2a. We can use this whenever we have a quadratic, ax squared plus bx plus c. Whenever this equals 0, we can use that. So let's look at an example here. My first example, I'm saying solve this with the quadratic formula. We're just going to use this over here. And the a, b, and c here are 5, negative 18, and 9. So a, b, and c is just referring to those numbers. Don't look at the x's, don't look at the variables. We're just looking at the numbers, the coefficients, and we're going to plug these into the formula. So first of all, negative b, I'm looking at negative 18. The negative is going to change that sign to positive 18. Remember, a negative negative is a positive, plus or minus the square root of b squared. So I'm doing 18 times 18, 324. And then minus 4ac. So I'm doing 4 times 5 times 9. And this is all over 2a, right? So 2 times 5 would be 2a. All right, and really to solve this, we're just going to simplify all these numbers with PEMDAS, working inside this radical first and just seeing what we can simplify. All right, so let me change my color here. Our next step, just trying to simplify what's inside. I'm going to bring down this 18 plus or minus the 324. So next I can do 4 times 5 times 9. That's going to give me 180. All right, and then on the bottom, 2 times 5 is 10. Okay, next I can subtract these. So let's bring this down again, 18 plus or minus the radical, always just bringing down the things that we don't change. Here I'm subtracting 324 minus 180. That's going to give me 144. Bring down the 10. And the square root of 144, of course, is 12. So let's bring down all these things that we didn't change. So what's going to happen here is the plus or minus here is really going to give us two different answers. First, we have to add these numbers, and then we also have to subtract them. So first of all, let's do 18 plus 12 over 10. So adding these numbers, 18 plus 12, that's going to give me 30 on top over 10 on the bottom. And then if I just divide these, 30 divided by 10 is 3. So one of my zeros, or we could say roots, one of my answers here is going to be 3. To get the other one, I just need to do now 18 minus 12 over 10. So 18 minus 12 is 6 divided by 10. Here, instead of dividing this, instead of getting a decimal, let's just go ahead and reduce this fraction. So instead of 6 over 10, I can reduce this to 3 over 5, 3/5. So both of these answers would be our zeros. Both of these would be our x-intercepts. For example, if we were to sketch the graph here, if I made a little graph, one of my x's would be 3, so I would just count 1, 2, 3, and put a dot there. One of the x-intercepts is 3. The other one would be 3/5, which is kind of in between 0 and 1, sort of right here halfway. Right, so if I were to sketch this parabola, it would sort of look something like this. Here's another example. I'm finding the zeros of this function, but I can actually skip the quadratic formula on this. There is a shortcut. So this is already factored. And if I'm finding the zeros, that just means that I'm setting this equal to 0, which means I'm setting both pieces, both factors to 0. So let's do this one first. I could first of all say negative 4x minus 3 equals 0. And I'm really just solving this like a normal equation. I would add 3 to both sides to get negative 4x equals 3. And then to get rid of this negative 4, I'm just dividing both sides by negative 4. 3 over negative 4. So one of our zeros, the first zero, would be negative 3/4. And then I just also need to do this factor as well. So here I'm just setting this also equal to 0, x minus 3 equals 0. And this one, just one step, really pretty straightforward. I just need to add 3 to both sides. Okay, so pretty straightforward when it's already factored. We can just set each factor equal to 0, and we could really skip the quadratic formula. You could also use the quadratic formula and you'll still get the same zeros. Okay, so one last example here. On this one, we're actually going to use both the quadratic formula and the vertex formula to graph the parabola correctly. So first of all, the vertex formula is just this, negative b over 2a. And in this example, so let's do the vertex formula first. In this example, negative b is 4, so negative b is negative 4 over 2a. Here the a is an invisible negative 1 in front of that x squared. So I'm going to say 2 times negative 1. And let's just go ahead and simplify this. So this is going to give me negative 4 over negative 2. The negatives would cancel out here, so this is just going to be a positive 4 divided by 2, which just gives me 2. This is the x-coordinate for the vertex, and to get the y-coordinate, I really just need to plug this back in to the original equation. So this is going to give me negative 2 squared plus 4 times 2 plus 1. The negative is not included with the square. It's not inside parentheses like this. So really I'm doing 2 squared, which is 4. And I just bring down the negative sign. Over here, 4 times 2 is 8. And then plus 1. Adding all these together, I'm doing negative 4 plus 8 plus 1. It's going to give me 5. So our vertex for this is 2, 5. The x is 2. And the y is 5 for the vertex. And I could go ahead and plot that on the graph. So here's 2, 1, 2, 3, 4, 5. This will be the vertex of the parabola. The second part of the problem, I also need to use the quadratic formula to get the zeros, to get these x-intercepts. All right, so I'm going to use negative b plus or minus square root of b squared minus 4ac all over 2a. So here the b is 4. That means I'm going to use negative b plus or minus the square root. B squared is, I'll just write it out, 4 squared minus 4ac. So a is negative 1, c is positive 1. This is all over 2a, just like that. Again, we're going to use PEMDAS here to simplify this. So let's bring down things that we're not changing. This radical, 4 squared is 16. Then I'm subtracting 4 times negative 1 times 1. So this is going to be a minus 4, which will change to a plus, right? A minus minus is going to change to a plus. 2 times negative 1 is negative 2. And let's bring these down. So I'm going to do 16 plus 4. That double negative is going to give me 20 all over negative 2. For this one, let's approximate with a decimal instead of leaving it as a radical. Since we're graphing it, we want to know where this is going to be on the graph. So the square root of 20, let's just say 4.5. We're going to kind of round that. Negative 4 plus or minus 4.5 over negative 2. And again, we're going to get 2 answers here. Okay, and then I can also cancel out these negative signs. I have a negative on top, negative on bottom. I can cancel these two, make my life a little bit easier. So let's go ahead, we're going to get 2 answers here. Let's go ahead and add these first. 4 plus 4.5 over 2. 4 plus 4.5 is 8.5, and then divided by 2 is 4.25. So on the graph, it's going to be 1, 2, 3, 4, kind of in between the grid line here, between that 4 and 5. We also need to get our other 0. So this one is 4 minus 4.5 over 2. Subtracting these, you're going to get a negative 2.5. Sorry, negative 0.25. And on the graph, that's going to be right in here in between that 0 and 1. As we graph these, we're just really connecting these with a curved parabola. Just like that. It might be off by a little bit, but as long as your zeros and your vertex are in the right place, that is good enough for us.